Just introduction, applied. You see, applied. So it's headache every time if I teach the biostatistics for many reasons. The reason number one, really, the sources, available resources in biostatistics, really it's big for the clinician. If you go to the library and you to see the list book is like 200 or 300. This is the list book, okay? So it makes sense because it's written, all of these books written by expertise in biostatistics. But really, as a clinician, we don't want all of those, okay? This is I'm going to assure you, we don't need all of this information, but we need the basics and apply. And then my recommendations, my advice to you, to work in a teamwork. If you don't have too much information about biostatistics, why not to work in a team? Why not to involve a biostatistician with you, or a physician who has a good knowledge about biostatistician? Okay, and then my advice also to start knowing, is it okay? I'm going to give you scenarios. Some people say no, I want to start in research without knowing everything about biostatistics, but it's very tough. But why not to know the basics and then start, and then every time you will know more and more. Okay? So when I say applied, because we're going to teach you SPSS. If you go to the SPSS, which is the statistical program like Excel, but it's more professional than Excel, the first thing on the SPSS, as you put any variable, he will ask you which kind of variable is. Which kind of variable? What do you want? Okay, 3 measures variables. So you see scale, ordinal, nominal. So what are of those? So the first thing we have to know about types of variable. We spoke about variable yesterday, and then most of the people didn't know what does it mean variable. So we have to know first about variable. Okay? So what does it mean variable? It's a record. Good. As the name implies, varies. It varies. So my height is 170. Your height is 180. So it varies. My hemoglobin is 14. Your hemoglobin is 10. It varies. Okay? So I responded to the medication. It's yes. And you didn't respond to medication by no. All of those are variables. Okay? So simply, the simplest way to know the variable, first look for the variable. I'm just giving examples: weight, gender, and then what types. Okay, what are the types of variable? Okay, any variable, ask yourself first: is it numeric? Does it have numbers or not? What about height? Yes. What about weight? No. Hemoglobin? No. Creatinine? No. Okay, all of those numbers. It will be numeric, which is continuous, which is the scale. Many number and many names, but it's a numeric. On SPSS, it's named as a scale. That's okay. Like what? Numeric, like age, pulse, serum creatinine, hospital stay, okay, and all of those. And then, if it doesn't have numbers, it will be, I will say it's non-numeric now, okay? And then there is sub-classification, which is, if there is hierarchy, what does it mean, hierarchy?
Like childhood.
Okay, like senior consultant, senior specialist. Like stage, levels. Okay, so like grade 1 of the tumor, grade 2 of the tumor, grade 3 of the tumor. Stages of the cancer, T1, T2, T3, T4. Can I say T1, T4, T3, T2? No, it is ordinal. Okay, like tumor grade, scale. And then finally it is anything else will be nominal. Nominal means, does it mean it doesn't affect if I change the order? Male, female, female, male, yellow, green, blue, blue, yellow, green, no problem at all. Yes or no? But we usually start with no, but it would not affect the meaning. Okay? So nominal, like gender, race, complaints, hematuria, flank pain, dysuria. I say dysuria first, I say hematuria first. That will not affect the meaning. Make sense? Exercise? Exercise. Can you open, it is already on the, do you have the handouts? Can you open the handouts, please? Anybody can read? افتخار, yes. Can you read?
A questionnaire has been done for people who attend to the Royal Hospital to assess their level of satisfaction. The following questions were included in the questionnaire. Please determine what type of each traveler.
Answer the first one.
Gender. That's mean what is the female or male?
Ask yourself first. Does it have numbers?
No.
Non-numeric. Does it have orders?
No.
No. It will be nominal. Okay? Second one. Numeric, exactly.
Have you had any surgeries done?
It will be, the answer is yes or no. It will be nominal. Okay? Next. Doctora? Yes or no? In yes or no? In yes or no, nominal. Okay? Dr. Muhammad? Scale. Scale. Ordinal. In scale? Ordinal. Imprinted in your mind now? We are going to build on these types of variables a lot of information now. Okay? So, how to express data? This is important. So, the first we are going to express is nominal, because nominal is easy. So, how to express nominal? Just wait. I have, this is part of my research. I have 305 patients, and those I have male and female. No other options, male and female. How to express them? Is it okay to come to you in my presentation said, patient number 1 is male, patient number 2 is female, and patient number 3 is female?
No.
Does it make sense? Very. Is it a better way? There is a good way?
No.
How to express nominal? Okay, shorts. Okay, you need number expression first, not graphics.
Code number.
Percentage. Exactly. So frequency and percentage. So easily I can say 80% male. Don't say 12% female. I'm writing manuscript. I'm writing only, for example, 60% male. It's already known. I write on my script, for example, my patients, for example, 55 on the right side, in the kidneys, for example, it's already understood. That's 45 on the left side. That's it. So any nominal variable, this is okay. You can express by percentage and frequency. Okay, this is by number. Okay, if you want to do a graph, what is the most suitable graph?
Pie.
Exactly, pie chart. Easy. So how to express nominal? By percentage, and graphically by? Easy. Can you go to the next? Okay. I have now ordinal. I have my patients. You see, look. I have grading. You see, tumor grade. Grade 1, grade 2, grade 3. How do you express them?
Number.
It could be a table, but we need, in answering, try to answer by numbers and the graphics. We need two answers. Okay, which kind of chart? Column chart. Column is okay, pie okay. It's okay, but classically bar chart or column chart. Type numbers, how can you express them? Percentage the same. Okay? I will say 61% were grade 2. And this is the column charts. If you look, if I present this chart in my presentation, and this is the numbers 200, I can understand like 190 patients, okay, of grade 2, without saying. If I didn't say, you can understand now. This is the numbers, and this is 50, okay, and this is 100, and nearly 100 of grade 3, and like 20 or something, or less than 20 of grade 1. So, the aim of biostatistics to make life is easy. Instead of giving all of this information, you can give single graph that represents the whole information. So nominal is done, ordinal is done, coming to numeric, okay, which is a little bit tricky. Okay. How to express the body weight and height?
Range.
It's not bad. Range. Okay. So there's something named normally distributed data and something named non-normally distributed data. You will understand it, don't worry. Okay, but think about now normally distributed data. The difference I will explain. But what about to say mean and standard deviation? You will understand what does it mean standard deviation. This is, you can't go outside this course without understanding the mean and standard deviation, because it's crucial. Okay, so now I understand that if you say to me the mean, so most of the people around which weight? 80. And I will explain this later, don't worry. Okay, and then the same height. If the data is, look to the next data. So the range, the median between 6 and, very wide range. So I expressed here by median and range. Okay? So just to put in your mind, normally distributed data, the expression is mean and standard deviation. Abnormally distributed data, expression by median and range. Again, normally distributed data expressed by abnormally distributed data by. It is crucial. Hundreds of mistakes in manuscripts because people do not understand what does it mean normally distributed data, abnormally distributed data, and they express data wrongly. Okay? Go. Okay. The numbers has distribution. I will explain now. The distribution is something named normal distributed data and abnormal distributed data. Forget abnormal distributed data now. So if you wanted to express numeric data, express it by mean and standard deviation. Just keep it in your mind, and then I'm going to explain. And which kind of chart? This one. What's the name of this chart? Think. Histogram. Yes. So graphically, you can express numeric data by histogram. Okay? And you see here the distribution. Here is the body weight, and here is the number, the frequency of the people. You can see around most of the people cluster around 80 kilograms. You see, you can hear this is 50 patients, like 48 patients, here like 45 patients. So if you have a log, single log, you can get more information, the whole information from this histogram. So the histogram has two axes, X and Y. On X, the full range of the body weight, and the Y, the numbers. But in column charts, you put only the possibilities, grade 1, grade 2, grade 3. Okay? Just, did you get the last information? We're going to press more, okay? What is median? Just wait. I will do now a question, a test, quiz. Okay? And then I'm going then collect you are like 22. And then I corrected the quiz. Okay? And then I collected the whole scores. If I collected the whole scores, and then Mr. Ace asked me, what is the score? This is the first way. Student number 1, he got 70 from 100. Student number 2, he got 75. Student number 3, he got 55. I can express data by this way, which is very rude. However, if I say to him the mean is 75, he will see now, okay, the mean is 25. That's okay. How did I get the mean? Divided by the number. Easy? This is the first concept. You have to know about mean. So the mean is
Sum of our data divided by the number.
Divided by the number. Alaykum as-salam wa rahmatullahi wa barakatuh. Easy? So the mean expresses something named central tendency. What does it mean, central tendency? The cluster. Most of the people cluster around 75. I can understand now most of the people, like, for example, 2/3 of the scores around 75. Okay? But if I say to him the mean, if it's a score from 100, I say to him, very depressive. The mean is 30. What does it mean? The people clustered around 30. Most of the people are failed. But I said to him, I am proud. The mean is 95 or 90. What does it mean? Yes, the people, most of the scores are nice. By single word, I expressed the data to him. Okay? Central tendency and mean. Going to median. If I return it back to the last example, you see? 50? 3? 60. Okay. They are near to each other. But next I added 95, which is extreme data. And then here the mean was 55. And then if I calculated the mean again, it will be single data, okay, or single element. It changes the whole mean because it is extreme data. Okay? So you can understand now mean is a good expression if the data has or clustered by normal distributed data. However, if you have extreme data, it could affect the mean. So I can't express by mean because mean now is not representative. I will express by median. I will express by median. So when do you use median?
Extreme data.
If the data extreme data or if the data is abnormally distributed. Median, okay? Median is a central tendency. How to calculate? Collecting the scores divided by numbers, easy. If the data is extremes, we are going to use the median. Okay. Although the computer now automatically calculates the median, but I wish from you to know just the basic. Median is the middle value. If your data set has odd number, whatever the values, I'm just to choose here a simple example. Just I put numbers from 1 to 7. So what is the median here? Simply the median is, yes, the middle value. Whatever the data on the right side, whatever the values on the data on the other side. This is the way how the computer calculates the median. If your data set has even number of values, I choose here from 1 to 8, you can't say the median is 4 plus 5, but simply we say 4 plus 5 equals 9 divided by 2, so the median here is 4.5. I'm going to give you this example to understand. You will understand more. Okay. Can you read?
I had an exam on applied biostatistics and I got a score of 76 over 100. What you can tell about my score? Excellent, good, fair.
Answer this question.
Can't.
And then good. And I'm good.
Fair.
Fair. I'm fair. You are right. All of you are right. Exactly. But I wanted to say from you, I wanted to hear what's the standardization. Okay? You gave all the possibilities because I didn't give the mean. Exactly. Okay. I'm going to answer you again. Okay? I'm going to just delete the standard deviation now, but I'm giving you the mean now. If I say to you the mean of the people is 60, I am excellent. But if the mean is
Fair.
I'm okay, I'm fair. Okay? So now you understand why we express by mean. If I say to you, okay, so the examination, they report the international examination by mean and standard deviation. They give you the score of 200 and then you give you the mean the mean and standard deviation. Okay. This is one of my studies that has been published on Clinical Genitourinary Journal. Just I'm going quickly to the section of the material and the methods. Just here see the data collection. At the end of the material and the method section, you have to describe your statistical analysis. So data collection using SPSS such and such and such. I'm going to focus here on the statistical analysis. Frequencies and percentage were used for nominal and categorical variables. You see, this is exactly what we explained earlier, okay? And then the mean standard deviation was used for normally distributed. Otherwise, the median and range were used. Exactly. I want from you to know those two phrases only on writing the manuscript. You have to prescribe your statistical analysis. Okay. Just going quickly to the results. When we described the age, we described it with, yes, mean and standard deviation. As we wrote here, the mean age of the study population was 59 plus or minus 11 years, which is the mean and standard deviation. And when we described the follow-up period, that was 34 months, we described it with the median and the range because the range is the range has a lot of extremes, 6 to 300 months. So here is the description. Just this is a simple application of what we learned. Just we are going to now to go to the SPSS for the second application. I prepared a simple data view for SPSS just for demonstration. I brought only 4 variables. One is nominal, other one is categorical or ordinal, and one is normally distributed, another one which is abnormally distributed. I will not speak about SPSS because we have many lectures on SPSS, but I'm going to give you the simple application on what we have learned together. Here just gender, we give the gender nominal, and the tumor grade we give it ordinal, and we give for both the weight and the creatinine scale or numeric data. Just you have to know that each variable has a specific analysis, and you have to know which kind of variable to choose the correct statistical tests. Okay. So I'm just going to here quickly to analyze frequencies. As we said before, frequencies, we are going to use frequencies for, yes, nominal and ordinal. So I'm going to put first gender, which is nominal, and then here the charts. This is only one option here. You can't choose pie chart and the bar charts together. I will start with pie chart for the gender as example of nominal, and just click OK here. You see here it gives you this simple table, and the male here is 88%, and so subsequently the female is nearly 12%. And this is the pie chart, shows the majority of the study population was male. And then I'm going to go quickly just for demonstration to put the tumor grade, and in this variable I'm going to choose bar chart and continue. You see here it gives me the bar chart. As you see here, grade 1, grade 2, grade 3, and here is the bar chart. As I explained in the lecture, here is the x axis and here is the y axis. If you click here, just a lot of options. I will explain later. Just I'm going to show you, you can put the data here. If you I click here, you see exactly here the numbers. So here this is a 200, it's nearly 170, and this column is at the 100. So the SPSS wrote for me there is 100, and there was only 18 patient with grade 1. There is too many options here. Just the simple option that many people asked about, the colors. If you wanted to choose another color, if you wanna choose blue for example and yellow, okay, you can choose whatever you want. And here is the fill. This is the fill, and here is the border. So you can change the fill and the border as you want, and you just click apply, and I change them. And if you close this window here, it's saved here.
Simple thing also, most of the people do not know it. Just right click and instead of copy it and paste, just if you click export, you can keep this this graph on PDF, or you can keep it on, or you save it into a PowerPoint presentation. Just I kept them for you just for to save time. This is the PDF, okay, and here is the PowerPoint if you want to keep them or to save them into PowerPoint. Okay, going again to the analysis. So we did analysis now for the nominal, and we did for the categorical. Finish the frequency. Just to go to descriptives. This is a simple one. If you can choose, if you want just a simple data, you just there's a lot of options here. I will not go those. Just keep them now. Just here's this basic descriptives. You see here the body weight and the creatinine. The minimum is 44, the maximum is 125, and the mean is 80. You see the standard deviation. A simple area, just you can figure out by this area which type of data, even if it is normal distributed or abnormal distributed. So just bring the standard deviation and multiply it by 2. It should be so far from the mean. You see here is 15 multiplied by 2, which is 30, which is so far from the mean. It means that this data is normally distributed. However, if you bring this standard deviation was 1.3, which is a little bit close to the mean, if you just multiply the standard deviation 1.3, it will be 2.6, nearly double the mean. That means that this data is abnormally distributed data. This is something simple. If you want more analysis, go to Explore and just put the body weight and the creatinine, and go to the plots. You can choose the histogram. No, I will hold the steam and leave now. You see here, just I'm going to show you the histograms of both. This is the typical histogram of normal distributed data. Just I will click here. Just I'm interested just to show the distribution curve. You see it is a bell-shaped curve here. Okay. And as I explained before, this is a mean and standard deviation. See here, there is not too much extreme data, so the mean is still, it is representative of a normal distributed data. However, if we go here to this histogram of abnormal distributed data, see how many extreme data, a lot of extreme data that it changed the mean. And if you click here and you choose the distribution curve, it is skewed data. Okay, so it's not normally, or it is non-normally distributed data. So how to express normally distributed data and abnormally distributed data? As I explained earlier, if the data is normally distributed, express it with mean and standard deviation. However, if the data is non-normally distributed, simply express it with, don't express with mean, just go to the median and range. So I will say here's the serum creatinine, the median is 1, open parentheses, range 0.1 and 11.6, those are the ranges. That is enough now just for a simple or basic application on SPSS. In a summary, types of variables quickly, if the variable has number, it will be numeric. Okay, like age, pulse, serum creatinine, and all of those. If the variable doesn't have number, it will be non-numeric. And based on the hierarchy, if the variable has hierarchy, it will be ordinal, like tumor stage, tumor grade. Or it doesn't have hierarchy, it will be nominal, like simply like a gender. Okay, so just also a quick review or a summary of this lecture. So you have to express your data. I will express my data based on the type of variable. We have 3 kind of variable. If it's nominal, I will express it with frequency and percentage, and pie chart is the graphic representation, and ordinal also can be expressed with frequency, percentage, and here the bar chart or column chart is the option. Numeric, if data is normal distributed data, can be expressed with mean and standard deviation. However, use median and range if non-normal distributed data, and histogram is the graphic representation of the numeric data. Next lecture, we are going to explain in detail the standard deviation, normal distributed data, and non-normal distributed data. Thanks for having me in, and the best of luck for all. Thank you.